All right, so we have some homework coming due Friday, so let's have a look. Okay, there's three equilibrium problems actually. There's 171, I think it's 173, and then what was the number? 182, I think. So let's have a look at this. All right, so the first two of them are two-dimensional problems. So we've got kind of cable systems with some sort of force applied. And let's have a look at this one. So we've got FAB and FAC. Those are the two forces in the cables. And we're pulling A to the right with 860 newtons. So we'd like to find the forces in AB and AC. Okay. So do we have any questions on that before we... For starters, anybody questions?
So you just set them equal to 0?
Yeah, and you use some trigonometry on these would be the thing. So yeah, the deal with this is you do have to do a fair amount of trig. So when you're doing these, you want to draw a free body diagram. You want to be sure to do that. Another word for that is just a force diagram. All right, so you want to draw a free body diagram that includes the cables, because by doing that you can find the forces in the cables. So I could draw a free body diagram like that, and my intent there is to find the forces in AB, AC, and then that horizontal cable. So if I cut that ring out, and then I'll look at what the forces are in the cables that are required to hold it in equilibrium. All right, now the way you approach these is you go sum of F is 0, and really that's a vector equation. So there's two versions of this that you can use. Sum of Fx is 0, and sum of Fy is 0. So that's two equations. So the thing to do then is to use some trigonometry there. So you've got enough of the dimensions here where you can work out the angles of the cables by doing inverse tangent. And that will allow you to find the angle of AB and the angle of AC. So they're shown there on the sketch. So in a free body diagram, I want to show the forces, but I also want to show the angles at which they act. So I'd start with that. And then you've got two unknowns and you have two sets of equations. So between that you should be able to solve. And it does involve, using vectors and getting components of forces. So what I would notice with this is that I have this unknown. When I break up these forces, I'll have horizontal and vertical components. So the horizontal components of those forces would both go to the left. And being as I have the angle with the horizontal there, that would be cosine for those. And then I also have vertical forces, which I would use sine to find. Okay. So when I'm setting these up, I like to start with the simpler of the two equations first. It just makes working through the algebra a little simpler. So I would probably then start with sum of Fy is 0. Okay, that's the simplest equation. And I can set up a nice simple proportional relationship between AB and AC, and then I can substitute that into sum of Fx is 0. That's how I would look at doing that. So that's the cleanest approach I could take. You're doing basically a matrix kind of solution here. You can approach it that way, but I would just approach it as a substitution in multiple equations and unknowns is how I would do that. All right, so that's the approach I would take. All right, so I'm going to start with sum of Fy equals 0, and that will allow me to relate AB to AC directly. Okay. So there you go. So sum of Fy is 0. Sine of the angle for AB up, that's going up, so that I'll use the sine function for that. So I'm opposite the angle. I mean, really, you can think of the triangle as being right there. I'll just move it over to the ring, and then I have this here. So I'm getting those two components. Sine 26.6 FAB, positive up, and then the AC is down, so that's negative sine 53.13 FAC. and then I can just work through that algebra. The sum of those two is 0. What I can end up with here is that AB is 1.79 times AC. So you'll notice that AB is at a flatter angle. So to get the same y component, it needs to have a higher force. That's what's happening there. You're kind of taking the relationship between the sine functions to get how those two forces relate to one another. Okay? So FAB is 1.79 times whatever FAC is. Then after you've got that, you can set up a sum of FX equation and include the 860, and you can substitute those into your FX equation and solve. Will be the strategy on this one. Okay. All right. All right, so we'll start with that, and then we'll generate a sum of FY equation next, and then do this as a substitution, solve for FAC, and then back solve and solve for FAB. And so the intent here, we use this equilibrium so we can know all the forces that act on an object. So when we go ahead and run this equilibrium, we can find the forces in the cables, AB and AC, and then if you know the strength of the cables, you can be sure that they're strong enough. And then you can also find out what's happening to the ring, all the different forces acting on the ring. All right, so the next step on that, once I've got that, is to go sum of Fx is 0. Okay, because I have substitution ready to go here. So I can get the x component of AB, the x component of AC. They're both based on the cosine of the angle times AB and AC. They're to the left, so they're negative. And then I've got the 860 to the right. So I can just go ahead and run that equation now, and I'm going to end up with 0.894 FAB plus 0.6 FAC is 860. But I know that AB is 1.79 times BC, so I can just put that down there. That'll get me one equation with just FBC, and I can solve for FBC. It's 391. Put that back into that original relationship there. FAB is 1.79 times the 391. It's 699. Okay. So that's the deal with that. Okay, that's the basic solution approach. And trig is very important on this. So what we're doing here is we're using adjacent to the angle, we're using cosine. Opposite the angle, we're using sine. So adjacent is the x component, and opposite is the y component. So cosine for the x's and sines for the y's on this one. So that's the basic approach on that. So we got any questions on that? All right. Now the next one's 173. It's similar to this one. Quite a bit similar, really, at least in how it begins. So 173 looks like that. Are there questions on this one?
Is this where we're going to use like gravity? We're dealing with mass.
Yeah, right. So you're going to want to find the force caused by that. Now all that's going to do is go around that pulley at F, or excuse me, at D. So you'll want to find the weight associated with the 30 kilograms. And the weight will be the force. So you'll end up with that force pulling on B. Okay? And once you've got that far, it's very much like the one before. Okay? It's very similar. Okay? So anytime you have a pulley, you're going to have the force on the cable on one side of the pulley, if you're dealing with statics, will equal the force on the other side. So, if you look at the pulley, basically you'll have that. If you look at the ring, that force will pull the other direction. You look at the object that you're creating a free body diagram of to determine the direction of the forces. So that cable from B to D is pulling, and so it pulls to the left on the pulley, it pulls to the right on the ring. So you'll end up with free body diagrams that look like that. You'll need to find these angles and then just go ahead and do the same sort of thing that we just did. Okay.
Do we do a free body diagram
On
on E?
E?
Yeah.
Yeah, you could. If you did it for E, essentially, I mean, E would be down here. You're going to have the weight going that way, and then it's in equilibrium, so that will also, we'll call that FE. That would be FE going up, which is FE going down, which is then FE doing that. I mean, that force kind of works its way all the way through to where it ends up pulling on the ring. Okay? So it's just kind of working its way around. Okay. So the weight is equal to mass times gravity. And you just work your way around. So, okay. So, and then also I'd like you to find the angle that for DF. Okay, here's D, here's F. See if you can find that angle right in there. You can call it whatever you want there, but I'd also like you to do that. That's a pulley on a cable there going, the cable goes from D up to F. So we got any other questions on that one? All right. So that's that one. Pretty similar to the one before. There's also that extra question there, finding the cable angle. There's a lot of ways you can find the cable angle. Just show me your methodology, however you're doing it. I'd encourage you, if you got, talk to your friends about that one too, see if you can come up with a good method on that. It's fairly straightforward if you kind of can see what's happening with the cable. The math is very simple to do it. Always encourage you to work with other people on that stuff. All right. All right, then we've also got a 3D equilibrium problem, 182. Okay. And what's happening there is we've got this ball that's being held at the origin. Again, we've got more cables here. So we've got 1, 2, 3 cables, OA, OB, and OC. And then we also have that wind force. So this is that deal where I've got it, kind of the approach on these things that's outlined on that page that preceded this problem. So it's 248 kind of has the process for this. What you want to do is come up with Cartesian vectors for the forces. And then once you have them, put them in columns. And then the row, and you're building a matrix. So the columns are the forces and the rows are the equations for the X, Y, and Z directions. And then it's a matter of solving out the equations, okay? So you're given where OC is. OC is in the XY plane. You're also given the reference angles for the wind force, so you should be able to get a vector expression for that. So what you want to do with this is get basically a matrix set up. So you're going to want to have X, Y, and Z. And then you're going to want to have FA, FB, FC, and then F wind. Oh, and then the weight as well. So, and then F weights. And those will be the columns, okay? So we want to set it up like that. And then you just fill the forces in rows. So some of the forces will, some of them will just be based on the unknowns, and others will be based on the numbers, okay? So you just want to go ahead and fill that table in. So for instance, for FA, you'll notice that that cable goes in the negative y direction. So I would fill that in like that. FB will be a similar thing. FC, you just look at how that's oriented in the, given that it's in the XY plane. When you look at FC, you'll notice that this line here is parallel to the the x-axis. It's coming off the z plane, so that point is in the XC plane, this point C out here. Okay. So you're given that. You can work through that. Just as a check, you should at some point have 0.259 times whatever FC is, which is an unknown. Okay, you've got the three angles for the wind force, so you should be able to get that figured out as a with three components of the vector. And then the weight is 9,000 newtons, so that's going down in the z direction. So that should be a negative 9,000. Okay. All right, and then you're going to have all that kind of worked through. Fill in that table basically, put the forces in columns. The rows are then equations. So what you're doing then is you're going sum of fx, sum of fy, sum of fz, and then the sum of these will be 0 for each one of these. All right. So that's how that'll work. And then you just kind of work through. Now you can either solve that thing out like a matrix, or you can go ahead and just solve it out one equation at a time. I just did it one equation at a time. I got FA is 1279 newtons. I got FC when I did that to get the next one. And what I get out of that is FC is quite large. It's 35,630. And then I go sum of Fy and set that equal to 0. Whoops, sum of Fx, my bad. And that should get you that FB is 33,891. Now keep in mind that you may not get my exact answers. My general rule of thumb is if you're within 1% of my answer, you're probably good. You just have some rounding difference from how I did it. So if you're within 1% of my answer, you're probably fine. The one thing is, remember to carry 3 significant figures. If you start only carrying 2, your answers can start varying quite a bit from what I'm getting. Okay. So that's the approach on that. Are there questions on that one? All right, so we got any questions? We good? All right.